Okay, test. Hello, everyone. Let me just check that Twitch has caught up. Yeah, looks like I'm live. Welcome back to more of the compiler. So, on Tuesday, we made some progress on starting the analysis phase. There was still some parts were still a bit unclear to me, but we still did some of let's take the imports and let's see let's create the local scope based on what is being imported. And after that, I was still struggling to figure out exactly how do we represent the scope, and I stopped on Tuesday before actually continuing today. I've given some thought, and I think I have found a way to do a proper analysis of a module while having, recursive functions, mutually recursive functions, without needing to do tricky laziness tricks to be able to tie in a knot at the end. So, let's go. Let's go there, and let's go back. So there's a few things I want to change compared to what we did last time. Mainly, I had done this thing that I wasn't completely convinced by, where I had this analyzable class where I say that being analyzable is a property of a type, and each type defines its own analyze function. The upside of which is I can do things such as saying that any analyzable thing A wrapped within a with location can do the right thing and delegate to the type class method to actually analyze whatever that thing is. However, I probably want to do things slightly differently based on what I'm actually analyzing, and therefore I think I'm just gonna get rid of this type class thing. The other thing I'm gonna change is gonna go back to the monad file. This one, I have here this big scope names thing that's like a path, which is like a non-empty list of identifiers, associates a non-empty list of occurrences, the names, and maybe an accompanying declaration. And that is what was making tricky the fact of having several things in the given module that may depend from one another is how do I represent this solved declaration in a way that I can do ahead of time and still allow things to check against one another. Was a bit tricky. And I think the easiest solution is still to keep this idea of having a dummy resolved thing, a partially resolved thing while I'm going through the module, because most things don't require knowing the detail of the actual resolved thing as far as type checking goes and name checking goes. So what I think I'm going to do is I'm going to split this hash map in two. I'm going to keep the names on one end, as in the current scope, what is the canonical address name thing of this particular name, and to a given particular name, what is the associated declaration that goes with it, if available. So let's do that, and I think I'm going to rename scope, which is no longer correct, with the analysis context, because there's a lot more we need to keep track of. And this is going to be the analysis info. And I think, although it should not belong here, I am tempted to introduce temporarily a path alias. Do I have that in my AST already, or do I have something else? Path info is slightly different. Although I guess I might need the parameters. Hello, how are you? No, I need the parameters at some points, but not in the path, I think. I think I want to be able to say that foo bar points to this specific thing, and then in the point also having those names are those arguments are applied to the thing, rather than treating each type as if it were a different specialization. Or maybe I do want that. No, I don't think I do. Yeah, I'm doing great. I have a bunch of ideas for how to make progress. I've done this interesting thing of I prefer remote jobs because I like to have a lot of flexibility on my hours, because I'm not always going to be productive at set fixed times, and being able to work when I'm productive is great. And I've chosen a side hobby project in which I have fixed work hours, So I've spent the whole day being excited about like finally I have a bunch of ideas. I get to put them in practice this evening. Hey, thank you. I've used the same Homestuck profile picture for a decade, and I only changed 2 years ago, I think. So it's been fun. It's I see this picture and it's me basically. Okay, so um, I think I'm gonna introduce it here. I don't think I want to uniquely identify types fully qualified. For instance, if I have a generic type uh, user info parametered by like some type T, I don't want the name like the to have in my hash map of like name to thing. I don't want the parameters to be part of the path. I want that to be resolved at a later time. So I think I'm gonna introduce this path thing, which is just a non-empty identifier thing. And I'm gonna use that in my analysis context. So here I'm gonna have the names, which is gonna be a hash map from path to a non-empty list of name, which is the canonical name of something that uniquely identifies it across modules, across different contexts. And I am gonna have this second hash map, which will not have the exact same thing, which is going to be, and is unlikely to change as much, given the name, give me the declaration, which will be used for some type checking contexts. Now, is that enough? We are probably also going to want to keep track of what we are analyzing, because with this new approach, we are going to be able to handle like mutually recursive functions, normal recursive functions, but there are contexts in which we're going to want to be able to know where we are in the analysis to be able to realize that we have loops. For instance, constants will have some restrictions. A constant A can depend on a constant B because those can be resolved at compile time. But if then constant B depends on constant A, then that's mutually recursive constants. That's not allowed. So we need to be able to like realize that we are in such a loop situation. So we might need to add more stuff here. I have the location in the info, which is a choice. I wonder if I will want to have something like this. I'll figure it out as we go, I guess. The other thing I want to change is I think I want to remove the maybe t from the monad itself, with the idea of like the problem of maybe t is that there's no way to recover. And I will want to recover, as in I try to like do the analysis, the type checking, and name resolving of a given function in the module. It fails. I would like to attempt to still do the analysis of the other functions in the module to try to gather as many diagnostic messages as possible. And as a result, I need something that can be recovered. And the easiest way to do so is to wrap every single action that can fail in a maybe t and then recover at the calling level. So it's no longer going to be part of the analyze monad itself. Analysis info and diagnostic and analysis context. Okay. This has remained more or less the same. This is now called analysis info. And this takes the context as an action, as a argument. Yes, there are some naming conventions. Most monads you'll see are name something T because they wrap another monad that is below. M is a convention that I've seen a few times. So like, yeah, this is the monad that does the analysis. It takes I'm not entirely sure that like what the conventions around this are. I think most people would just like call it analyze. I like making it very clear that yeah, this is the monad in which we're doing things, hence the M. But I am not entirely sure what the convention here is. I've seen this M a few times, but I don't think it's universal. So yes, context here. This is a bit ugly, but that is fine. And now we no longer need this run maybe t because we are no longer in the context of a maybe t. I am tempted to make a change here. Here, this function like runs an action in the analyze monad, and as a result takes the initial state to be able to like run the action. I am tempted to instead run the monad with an empty state because populating the context needs to be done in the monad because populating the context can fail. Resolving imports, like sorting top level declarations, all of those things can fail, and therefore being in the context of this analysis monad that is accumulating diagnostics, pretty convenient. So I think I am going to do that. And as a result, change this to not take the context as an argument. And instead create an empty context with just, the empty hash map in both cases. Which means I will need okay. This should still be correct. Okay. Now, that means everything in here needs to change again. So here I can remove this swap run writer, run maybe t, everything. I can instead do a run analysis. I can gather the initial scope here, and I can probably do the thing I was saying of doing a run maybe t of this, basically, which gets like basically this action will be wrapped in a maybe t, and here I can decide, well, if I didn't get a scope, if I didn't get a initial scope, I can just fail early. And how do I do that? I guess the easiest solution would be, is there an easy way I can do that? I have a maybe value, and this whole thing returns a maybe value. There is probably a way to, I guess I could just run this whole thing in maybe t. Hmm. That might not be the worst idea. But that means I'll have to do... Yeah, I think that's fine. I think that works. So here, this is in maybe t over the analysis monad. And I think I could probably have the initial scope thing, since it's going to run in the monad anyway, I could have it be like set the state itself and just call it init scope instead, or init context. And that's dependencies. Then after this, oops. Yeah, I think this is no longer going to work. I was running the analysis monad on every top level declaration separately with the idea of let's gather all the diagnostics for each top level thing, which was a way of doing recovery. However, I need to keep some context across different things. So that is no longer going to work. Therefore, I'm going to need to do something slightly different. And I think what I'm going to do, let me just have a quick look at this. Hoist maybe is probably what I want, as in I probably want, or maybe T actually is probably what I want. I want something that wraps, yeah. I'm going to want to wrap the result of an expression that returns a maybe in the underlying monad to wrap it back into the maybe T. So that means that this is going to be... how do I do that? That's going to be a maybe t of do. And then here I can traverse analyze declaration of the module declarations, which will perform the analysis on each top-level declaration, hopefully doing the right thing. And then this gives me a list of the results, which I can unzip like I was doing here. There we go. And I just need then to do tail of the diagnostics, report them in the writer monad. And finally, I want to return the symbols only if all of those values here are like all adjusted. There isn't nothing in any of them, which I can get, I think, with a simple sequence. Yeah, that's basically what I was doing here. Okay, so what I want to do is I want to return a maybe value in the current monad, which will be from list applied to sequence of the symbols. Assuming that symbols is therefore something that can be transformed into a hash map, meaning a list of tuple name value. Or I could go even... No, I don't need to do that actually. I don't need to do any of that because now that I'm running everything in the analysis monad, each of them can do the tail of the diagnostics itself. So that's no longer required, which is good. I no longer need to do this unwrapping at this point. And now I'm tempted to... No, I still think I want to do this. I want every declaration to give me the thing because this hash map here will contain also declarations from other modules that need to be in scope. Therefore, I think I need to do... this, except sequence traverse is weird to me. No, I think that's correct. Except I might want to rewrite it as 2 lines just for readability. So that's going to be the symbols. And I want to do, yeah. Okay, and now I can remove this. Perfect. Except, do I want to do, I think here I want to do a run maybe t of this. Because analysis may fail. Okay, so here we are doing some unwrapping, rewrapping. Maybe I don't need to do that. Maybe I can do something simpler. Yeah, I think it's good enough. Now, init context needs to exist. It's going to be basically the same thing that we had last time with the initial scope, but fixed with our new ideas, which I'm going to rename this dependencies. I'm going to be consistent. So this hasn't changed. That's a list of known symbols. However, what we're going to do with this oh yeah, I remember this. That was complicated. So, because we were doing some deduplication that was kind of tricky last time, I remember. A hopefully monad, by which we mean something that like tries to optimistically find the like tries to avoid short circuiting when not needed. The thing is, I want to flip. I want to split this because this is the imported scope is the old hash map that had both name and dependency in declaration in everything, and that's not what we want. But the thing is, I might not need to actually carry this around with me. I might be able to just modify the scope as I'm going because init context is actually setting the context. So that means I can probably, rather than returning a bunch of lists and doing a bunch of list manipulation, I can probably just insert directly into the context hash map. There we go. Why do I use this resolved thing? I guess what I'm doing is I'm associating to each identifier a name and symbol. Yeah, I guess that's not too bad. I can make use of that. So, uh, this but I still have the deduplication problem of last time. Okay, how do I get rid of this without having to rewrite everything? So what we did last time was to reorganize, to do a hash map per module, so we could deduplicate, and within that module, do a union of the hash map so that the keys would be that was tricky. We might need to do the same. So maybe I don't change any of this. I keep it the exact same because that's the easiest. And so now I have this thing we have tried last time, the imported scope. Mostly I've never. Why I don't have. I need to get to remember the habit of reading the comments I'm responding to out loud because when I put the recordings on YouTube, the comments are not visible. The reason I don't have the ligatures enabled in Emacs is mostly laziness. I've never bothered. I never saw the appeal really. I just think it looks fine like this, so I've never bothered. So wait, yes, I'm doing all of this deduplication because I need to know. And symbol is not a great thing because it is a tuple of name and I've had this Emacs config for 6 years now, something like that, 5 years, and it works. And at some point, it's good enough. I think I'm gonna keep the same because this deduplication of paths is useful, and that means here. Do I want? Do I want to change this? Because here, what I have, I think it's in this file. Symbols is yeah. I don't have the canonical names of things in my dependencies, which is kind of a problem. Although I guess the symbol is the name is trivial to redeclare. Hmm. The name is trivial to redeclare. I guess. Oh, hello everyone. I am in the middle of trying to figure out how to translate a bunch of imports, as in import this module with those options, import this module with all other things, into a workable context and doing deduplication. I had something that worked last time, but I've changed some of the design of the data I'm keeping around, and as a result, I have to rewrite this. And I'm tempted to not change it. And as a result, here what I have, this imported scope, is a hash map from each possible path to a tuple of a canonical name and a declaration. And I can just split that. And I think that's the easiest. That means, as a result, that the known names, so a hash map from path to name, is going to be map first of the imported scope. And the declarations is going to be creating a map, a hash map, from the values of this scope, which are tuples. So if I get the list of values of my hash map, I get a list of tuples that I can use as key values. So that's going to be from list of the elements of this imported scope. And that way I don't have to rewrite this, which was very tricky because of this complicated deduplication here that I don't want to change it. So now that means I can set the current scope. Did I declare lenses on this? Yes, except I didn't update those names. This is analysis info and analysis context. Which means now I can do context names is equal to, well, I can just do that directly, actually. I don't have to introduce a new variable for it. And likewise, context declarations without the underscore is this. Okay. So that should put the scope in context. Do I need to change my handle maybe from last time? No, I think that is still correct. For a given monad writer in which I am able to write some diagnostics and a given diagnostic and a maybe value, yeah, I think this should be just fine. Because basically we want to short circuit the second we find something that just doesn't work. So this is init, I guess I'm going to say init foreign context, imported context. Now we can do init local context, which we had started last time and which is where we started running into difficulties. I'm going to change something real quick. Local is not a good thing. I'm going to change it. There we go. I guess I could initialize the context here in my monad with the built-in. That's probably something that makes sense because there's never going to be a need to actually add those. They're always going to be included. So let me do that quickly. Yeah, the dot equals is one of those lens operators. Lenses are I used to be on the record saying they're not worth the headache. I have changed my mind. I do think that I do still think that they have a high what's the word I'm looking for? Boilerplate cost, and like they have a high cost to entry. You need to use some template Haskell stuff. It messes up with your declaration order. There is a cost to using lenses, but they do make some things a lot easier. One of those is manipulating a state within a state monad, and what this dot equal thing does is it's just the lens operator, which is given that lens in the current state, set the value pointed to by that lens to this value, basically. And it has a bunch of other variants, plus equals, minus equal, and so on. So it looks like a very like imperative thing in a sense, and because that's basically what it is. There's something a bit weird about doing. They do need template Haskell just for the simplification here. Those make lenses thing are template Haskell. At compile time, they look at the type information from analysis, info analysis, context, and they generate a bunch of things in the scope that are basically the name of the lenses, context names, context declarations. I could write them myself without needing template Haskell, but that would be quite the headache, and therefore this is just here to just like generate that code for me. Hence naming my accesses with underscore, because that's the default name that lenses expect to generate lenses that have the corresponding name without the underscore. So if I have like underscore context names, underscore context declarations, then make lenses will generate context names, context declarations. Of course, there is a make lenses with. I can specify how to translate the names of my data type to generate the lenses for me. There's also make prisms. Like there's a bunch of template Haskell level. It's just to avoid having to do the work manually. And so yeah, thanks to lenses, I can just do dot equal here. And yeah, again, there's something a tiny bit wrong and magical being able to do like something like accumulator plus equal 4, and that just does exactly what you think it does. It feels imperative and stateful because stateful it is, imperative it is not, but it does feel like it. Okay, so now we have our imported context. This is now fixed with regard to our new types. There are people who criticize lenses under the premise of like it is too complex, and I think that is a valid criticism. You could probably break lenses into small libraries, like do one thing at a time. Like plated could be a separate library, for instance. But yes, lenses are absolutely magical. But they have, again, like the cost to entry is a bit high. That would be my main criticism. I have become convinced over time that like, yeah, no, they're worth it. Oh yes, the built-ins. I meant to. Is this useful? No, I don't think it is. I'm gonna rewrite this to be. Do I want, what should the declaration of int be? Do I want to have a kind of declaration for my built-ins so that my type checking can do a lookup on the declaration and be like, oh, it's just a built-in type? Maybe that probably would be a good idea. Which means do I want to make this as a hash map? It probably doesn't need to be a hash map, except for convenience for initializing the context. I think it's enough for the built-ins to be a tuple of like path, name, and declaration. Well, a list of that. Do I want to make it not a tuple? Do I want to make it a proper record? I think for now this is good enough, and we can change that later. So name is going to be built-in int, and the declaration, I'm going to need to change my AST to support a new kind of declaration. do I want to add a declaration for? Or could I just assume that if a type doesn't have a corresponding declaration, that means it is a built-in? Actually, yeah, I can do that. Sorry, yeah. So what I'm doing at the moment is the analysis phase. We have a parsed AST that corresponds to the source code that we have parsed, and we are not yet lowering it into AR. We're doing an analysis phase, which is both resolving names and type checking, and also probably some basic AST transformations, some basic optimizations, such as constant unfolding, as in like reducing a constant to its compile time value. And I started wanting to do this the same way GHC does it, as in a series of phases, a purely name resolving phase followed by a purely type checking phase. But I think this is less adapted to something like this, where we need to keep the scope through, like, for loops and while loops and such. So instead, I'm doing it as one phase, the analysis phase, where we're doing everything transforming from the past version of the AST to the resolved version of the AST. It is, I think, one of the two most complex parts of the project, and that's why I have been mostly struggling not with how to do it, but like how to find proper representation of things. How do I represent the data in there? The next part that will be a bit complicated will be the lowering into IR, which we have not started yet. When we have this like resolved, type checked, renamed version of the AST, generating the IR, because I'm aiming for a static single assignment IR, which is like basically a extremely simplified version of the LLVM one. And that is going to require like applying the algorithm of a research paper I've been reading to do like scope and flow analysis. That's going to be interesting, but we are not there yet. For now, yeah, the analysis phase. So given the raw parsed thing, doing all the diagnostics basically. Interestingly, this is the last part where we have to do error handling, because when we're done with the analysis phase, when we have resolved the AST of the module we have passed, any error that happens afterwards is an internal compiler error, because at that point we have, in theory, identified all of the errors with the user's code. So this is the last place where we have to do error handling, in theory, which is why in the trees that grows approach that I have done for the AST, I don't think I'm going to be using rewrites. I'm going to be doing some very basic simplifications, but given that the syntax of the language is already extremely simple, there is very little in terms of like syntactic sugar that can be rewritten to make use of a simplified version, like a core like GHC does. So I think no, I'm gonna, beyond constant unfolding, I think I'm not gonna do actual rewrites before lowering into AR, where we lower into a completely different language. Yes, the trees that grow thing. This is why I am dropping, like, at the past stage, the annotated version of a declaration is with location. At the resolved phase, the annotation drops the location, because when we are done resolving, we no longer care about the location in the source code of things, because we no longer need to report errors to the user. And as a result, I think this doesn't need a declaration. So my built-ins are just gonna be a path to a name, which is gonna be basically, I can rewrite it as this is a list comprehension basically. For name in, for now, int, and there's gonna be a few others. It's going to be pure name and built-in name. Okay, which means here I can initialize the context not with MMT, but with my hash maps of the built-ins, the things that are always going to be in scope, which is going to be a from list of the built-ins. No. Please ask as many questions as you want. Again, I've stated last time, it doesn't matter if this project takes 2 years. I have no deadline, which is a rare luxury for a project like this. I am always happy to answer questions. For now, I am gonna identify the idea of the name type I've been using is like it uniquely identifies each thing. Each thing has a name, whether it's a function, whether it's a type declaration, whether it's like a local variable within a function. It uniquely identifies it, which means if two things share the same name, they are the same. And that's what I'm going to be using to identify them, to identify types. And therefore, the way I'm going to do type checking is basically the type pointed there, is it the same as the type, does it have the same type, same name? And I'm going to do, when I do type aliasing, I'm basically going to replace by the pointed to name until I have the proper name for something. That name type checking is going to be fairly simple here because like our type system is fairly simple. But this idea of having a unique name that uniquely identifies a given thing is the way GHC does this. They, of course, do it in a more complicated way than we're doing because they are compiling a real language, not a made-up one. But that is the short of it. One big difference is GHC has, like, I think, if I remember correctly, within the name record, they have like an int that is like a UID basically, so that they can do fast comparison of things like do those share the same UID. For now, I don't have this. I'll just do basic comparison because performance is not something I've been caring a lot about yet. So yes, that's correct. Here, the built-ins are just a hash map from path to name, but they have no associated declaration. I can handle this manually when I see that something is a built-in. Now, local context. This is where things get tricky, because I need to be able to know about the things I'm compiling as I'm compiling them. For instance, yeah, basically, I'm going to switch to shapes when I do the lowering into AR. That is the thing I'm going to do at that point, because when I lower into AR is the point where the types kind of disappear, in the sense that at the IR level, everything is going to become kind of stack manipulation as much as I can, and a lot of the type information is going to disappear at that point. So that's when the shape is going to matter. Some of the shape is going to matter during the type checking phase, specifically in functions. That's why I want to have this pointer to the actual declarations. Within the function, I'll need to do checks such as, well, I'm accessing a field name X in this structure. Does the structure have a field name X? So I'm going to need that at that point. But beyond that, I think when I lower into AR, I'll be able to get to like use the shape, but then get rid of a lot of the type information. Or rather rewrite it into the AR form, which is going to be a lot simpler. Of course, there are still some parts of this for which I know what I want to achieve, but some of the details are still slightly hazy to me. My plan is basically to do what I've done so far, which is to like prepare ahead of the stream. I don't write code outside of the streams. That's like the self-imposed rule for this project. But I will sometimes take the time to like just like reread the research paper, reread some of the documentation, like recheck a few things, like how does GHC does this? So there's a few things about the lowering into AR where like I know what I want to achieve, but some of the details are still unclear to me. We'll get there when we get there. So next, the local scope. Again, the local context. This is where it gets tricky because if I'm compiling a function that is recursive, I'm going to need to type check against it. Like, oh, within the body of this function, I'm calling a function, which happens to be the same, and I need to type check it. Which means I need to have in the context something that tells me about this function, despite the fact that I have not finished analyzing it. So I will need to know the name in scope, and I will also need to know part of the declaration. I've been thinking about this, and one approach would be to do some not tying magic, where like I lazily construct a map from name to declaration, and that way each thing can like point to a yet unresolved thing that will be resolved in the future, and thanks to the power of laziness, it all ties up. But this breaks if there's any like fully recursive thing that needs to depend on itself. So I'm not going to do that. And instead, I'm going to cheat. And I'm going to use a partial declaration for the things that I'm currently compiling. Because to check a function that is recursive, I don't need the full result declaration. I just need the type. So I'm going to cheat a tiny bit. Which means here, in it locale context, the thing I had started, I'm going to change a tiny bit this signature because it's going to be running in the analysis method, which here this is also running in the analysis method. So this is a maybe t of the analysis m, and it does nothing because it just sets the context. And I think this one is going to be the same thing. And maybe t because this can fail because we can encounter some problems. Now, I'm going to rewrite this because I'm going to need to do a few more things. What I wanted to do here was I want to create a hash map I want to create the hash maps before setting them in the context because I want to be able to say, oh, there's already something with that name at the top level scope. We've messed up. There are more than one declaration with this name. Something is wrong. And I'm going to have to rewrite this a tiny bit, but the gist of it is correct. Maybe T, I guess, yes. So how do I want to do this? I was torn on like, should I do the error reporting at this point, or is it enough for me to just say, hey, this thing is duplicated in this module, and then let the caller actually look at the declarations to figure out where they are declared and what the error is. I'm still unconvinced about this. I think it would probably be better to like have the full information in this. So I probably want to have a hash map from path, which is the local path to the thing, so basically its name at the top level declaration, to its canonical name, which I need to do first. And that's going to be enough to already identify. And I guess I can do name and non-empty location. That way, I can do for any of them that has a non-empty location that has more than one entry, I can emit a diagnostic that a given name appears more than once at the top level, and then I can trivially obtain the hash map from path to name by, yeah, so I think that's the correct thing. That's what we need to do. Okay, so I don't think I need to do that in the monad itself. So this can be just top level names, because at this point I don't do the reporting in this. So this is just a simple fold L prime, or it could just even be better. It could just be a union with, I think. Yes, I think it's just a union on maps discards whatever, like discards duplicate keys, which is not what I want. So I want to do a full L prime of union with, and a function I am gonna define at a later point. Starting with the empty map as my accumulator. And the list I want to do this on is a list obtained by doing for each declaration in the list of declarations, obtaining the identifier. This is not properly aligned. There we go. And returning a tuple of the name, which is a top level declaration of this name, the module, and the identifier, which uniquely identifies, since module name is unique, uniquely identifies whatever this thing is, and a location, which is the location of this declaration. Actually, do I want? I might want to have. Do I want to have it with a location? Do I need this? It probably doesn't hurt to carry around the location of the declaration. Do I have? Except I don't have it. I don't have it for imported declarations. So no, let's not do that. Okay, so that should be good for this list. That creates the list, and then we create our hash map by. Oh, this is wrong. Sorry. This is wrong because I need to associate a path, this value to a path, and there will be more than one path per top level declaration because I can refer to a function in my module by its name or by its fully qualified name. If I'm in the module foobar and I have a top level function main, I can call it main or foobar main. So I need to put both paths in the scope. Let's do that. So this needs to return a list of 2 elements because I'm in the list monad here. And those 2 elements are going to be, so this is going to be the info, which is going to be this tuple. And I'm going to return a list of 2 elements. One which is a path made of just the identifier with the info. And one which is made of the fully qualified path and the info. Oh, if I do that, I will have, when I do my error reporting of like, oh, we have conflicts, I will need to be careful about not signaling the conflict twice, I guess. Or I guess this first map could just be this, and I recreate, yeah, and I recreate the fully qualified version afterwards. That might be better. Okay, let's do that. So now when I'm done with this, I have this top level names, which is a hash map from path to name and non-empty location. Perfect. So what I can do here is for all of the lists in that, actually, is it traversable? Because I think, yeah, that's for any traversable. Is a hash map traversable? I think it is. It is. So I don't need to do 4 to list. I can just do 4 on my top level names, and I will obtain a transformed hash map in my applicative functor. Yep, that's fine. So for all of the things in this top level names, oh, but I will be iterating only on the values, not on the keys. That's fine. So for each values in the top level names, I'll have a path, and I will have a name, and I'll have a list of locations. If the length of the locations, so that's is greater than 1, or I guess when greater than 1, actually I need this as well, then I will need to signal an error, which will be done by telling some kind of error multiple declaration. There we go. And I'm going to change the diagnostic to be an identifier and a non-empty list of location. So here I can pattern match on the name because I know the name is always going to be just... Actually, I could probably just like at this level for now, just make that... Oh, this is the... This is not an empty list. This is the... Yeah, okay. I will probably want to have... Here, I want to iterate on the list so that I have the key. Which means I have key name locations. I don't need the name, and the key is the identifier. There we go. And here, error multiple declarations, identifier, locations, which can then be translated later on as a proper error message for each declaration that appears more than once in the file. Perfect. The only thing left to do here is I want to put something in the result here that allows me to detect that some error happened. And I guess the easiest thing to do is just a Boolean. So has duplicates equal this or something like this? Or do I just want to do it with an if? No, I think I want to do it that way. It's going to be easier. When has duplicates report some errors, and then pure has duplicates. This gives me a list of booleans in my monad, and as a result, I can get a boolean by doing an AND on the result. And if, well, rather I want to do an OR. If any of them is true, if any of them has duplicates, then it failed. And if it failed, I am currently in a maybe T of the thing. And I can just do an M0, and that will short circuit. And I don't want to short circuit here because I want to signal all of the duplicates before short circuiting. Okay. Next, I have a hash map from identifier to name, and I can use that to populate the current context with my local names, which I guess I can do with context names. And here there is an operator, a lens operator I can use. And I think the one I want to use, I think it's something like this. Let me check. The curse of Haskell strikes again. I want the one that modifies the value in the state pointed by the given lens using the semigroup operator, but putting it first. And I think it is this. Prepare it to the head side. So I think this is close what I want, but I want the state version of this. There we go. That's this one. Modify the target of a lens by using the semigroup operator. Prepend it to the head side. Actually, that's not even true. Ah, damn it. That is not true because I don't want to just prepend them. I want to modify them because this contains a non-empty list of name, because I want to be able to know about duplicates. For instance, if I have something named foo in my module and there was something named foo in the imported thing, if I call foo in my local module, I need to be able to say, hey, which one do you mean in the case where they are used unqualified? So no, I can't sadly use this lovely operator. I have to do something a bit smarter than this. So this is going to be a modify, and it's going to be a union with. How do I combine those hash maps? I combine them like when the key is the same, apply the given function to combine them. And since in this case the value is going to be a non-empty list, then union with the semigroup operator. So I combine the ones I already had with a new hash map, and that new hash map is obtained by doing by transforming this hash map here into a hash map, which is actually identifier. A name, I want to translate it into a hash map of path to name, and I think I'm gonna do that first. Okay, so at top level names, that's already the name I have here. I'm gonna need to name it slightly differently. I'm gonna also introduce, so this is and I guess this is a somewhat similar thing here where I need to decide how I want to group two values which will have the same. So I guess this is basically combine locations, which I'm going to define here. Combine locations takes name one, location one, name two, which will always be the same, location two, and returns name one, location one, location two. There we go. And here, this is report an error if any declaration, if any identifier appears more than once. finally, add top level names to the context. So here, I'm gonna rename this as top level paths, I guess. And this is gonna be the from list where I'm gonna create the hash map by concatenating. And that's the thing I was doing earlier. Can I do something smarter? Can I do... Because I'm going to iterate over a hash map to create a new hash map. Is there a transformation thing that allows me to associate more than one value, not just one? Because there is map with key, but that's not what I want. I guess I could... I guess I could do a fold with key rather than going through... Yeah, I can probably do that. So instead of doing a from list of two lists of the previous hash map, let's do a fold L prime with key. Fold L with key prime, I think it is. Yes. The downside being that I'm going to have to... that's fine. I'm going to have to introduce a new function for this, which is going to be make paths, I guess. The starting function, the starting accumulator will be the empty hash map. And the hash map on which we're doing this is the top level names. So what is making paths? I'm going to get the identifier, which is the key, and I'm going to get the value, which is the name and the locations. And I don't care about the locations anymore. So now the result of this is... Actually, I'm going to get the accumulator first. Yes, so I'm going to get the new map. And the result is new map. It's going to be a insert pure identifier name of insert module name pure identifier. So the unqualified version, the qualified version name at the beginning of our new map. Well, beginning in our new map. Okay, so that is now the top level paths, and now I can do this nonsense here with this lens operator to modify my current context, to add all of those names to my context names. That's the union with semigroup operator of this, and I can probably just inline this. Okay, now my local context contains an entry for every identifier in my top level declarations, which means if I'm doing the analysis on a constant A and it references a constant B, I will be able to look up what is the name of B in this context. There will be an entry. And if there's more than one B in this context, I'll have the proper non-empty list of different names, and therefore I'll be able to say, did you mean the B that is at the top level of this module like with this name, or the top level in this module, basically? Now what I need to do is to associate to each name in this module a declaration. And that means I need to do a dummy declaration, or rather a surface level analysis of the thing, so that I have the bare minimum that is enough for type checking without actually going into details. And that's going to be, I think, a separate function, because this is already complicated enough. So this is going to be in its imported context. In its local names. I'm going to change this one to local names because it doesn't do init local names. It only needs the module name and the declarations. This name and mod declarations. And finally, the last thing I'm going to do is we are going to go through the list of declarations, and we're going to just do the very basic shallow analysis, just enough to be able to insert a I can't. I'm not like I don't have a large audience. I get a spammer every single time. That blows my mind. Give me one sec. There we go. One time a few weeks ago, I'm not super used to the Twitch interface, moderation interface. I actually gave a spammer mod powers for a very frightening few seconds until I realized what I had done and I immediately removed because I like mod button. Yes, I want to moderate this user. Oops. That was stressful. So at this point, we have done the initialization of the local names. We need to do the first analysis, the shallow analysis, which I guess we can do basically the same thing as this. As in traverse of run maybt. Yeah, I think this is all correct. Except here, I don't need to return anything. I don't need... Do I? No, actually I do. Except this isn't going to be the symbols. This is going to be the shallow declarations. And with the shallow declarations, I'm going to be able to modify... I'm going to be able to modify my context, which is context declarations. To just do the map, the union of the hash map of the shallow declarations. So this is the same. And here I do the same thing, except I return the actual hash map. And symbols is identifier to declaration resolved. Yeah, perfect. Except here, so shallow declaration will have to associate the name rather than the identifier. That's fine. Which means basically this needs to return something slightly different than this. So here this is going to be shallow declaration analysis, and this is going to be a full declaration analysis. Okay. I think that's correct. And now we just have to write the analysis. We've done everything else. Except, yeah, this analyzable class is going to go away. I'm just going to introduce in separation just because I want to see clearly that those are the helpers and this is the analysis. Okay, so this will all go away. I'm going to keep it just for reference for now, because I had some ideas that I think were relevant. So first, we are going to start with declarations. So first, let's have a look at this, we have shallow declaration analysis, which is a function that is going to take a with location of a past declaration, and it's going to return within the analyze monad. It's going to return a tuple of the name of this declaration. That feels a bit inelegant. That feels a bit inelegant because I know the yeah. I can simplify this. Okay. Sorry, I keep doing some back and forths, but I am trying to clean things as like not let things get too bad as I go. I think I'm gonna introduce just a few functions in my AST. I'm gonna go back to my declaration of declaration here, and I'm gonna introduce a small helper function, declaration identifier, that to a declaration associates an identifier. And which is just this, we get the associated name, basically. Which means here this goes away. This is declaration identifier of the declaration. Except no, I want the identifier, so I'm gonna put it here. Okay. And I guess I could add another helpful little helper here. Make top level name, which given a module name, which is the current module name, and an identifier, which I guess that's pointless. That function is just top level declaration, so I don't need to do that. What that means is I can go back to here in its local name, no, here in the actual function here, rather than asking each declaration, like each function that does the analysis, to give me the name associated with it, because that doesn't matter. I can instead would a declaration, it would know its name. It would have access to its name through the identifier. It's fine. That means here I can do but okay, no, I'm just gonna let each function return its own thing. That's a bit ugly, but that's fine. Okay. So this returns a tuple of the name and a declaration resolved. And that's wrapped in a maybe t, because this might fail. Okay. So this take as an argument a with location, which is the where the plate, like it's the location information and the declaration. I'm gonna do the thing I was doing here, which is set the location in the state. Well, not in the state, in the reader, actually. That way it is scoped properly. And with this, I can do this case I can do this case of the located information, which is the declaration, and now I am in the case of and here I can even do let name equals top level declaration with the module name, which I have actually, I keep giving the module name everywhere in those functions. I have access to it through the monad. I don't need to do that anymore. Sorry, I keep going back for some cleanups, but I realize that there's a bunch of things I have done that are no longer required. Run analysis here takes the module name, which means I don't need to give it manually. And where I need it, I can always just ask for it, which I can do. It was called this name. How is it called in my thing? It's called info uses info module name. Okay. And I can do the same thing here. Okay. Okay, so here, likewise, I'm gonna need to know the module name. The name of this declaration will be module name and the identifier, which is declaration identifier of this. And now we can do this case on the thing that we're trying to analyze and do a shallow analysis of all of them, which might not require a separate function because it might be fairly straightforward. Because if we look at the AST, for instance, the const info, the only thing we need to do for the const info is to resolve the type. The expression will just be left blank because this is a shallow analysis where this is going to be left empty. So the expression will be, I could perhaps even go all the way and make it something like an error that will fail if evaluated, as long as it never gets evaluated. But I guess I could also just like use some arbitrary expression that does not like do anything. As a placeholder because it's not going to be used at that point. It feels a bit ugly. I think I would prefer a solution where like I do some not tying stuff so that I never have wrong information in my tree, but that would be a lot more complicated and a lot more error prone, so I think it might be easier to just not do that. So, yeah, I think constants are going to be the only annoying thing. Because I'm going to need to know, I'm going to need to inline them. So I'm going to need to know, will I be able to... No, I can't evaluate them at this point during the shadow evaluation because they might use information about a type that hasn't been evaluated yet. So no, I am condemned to do shadow evaluation first. That's fine. Okay, so let's go back to it. let's start with, I think, a constant because it's the easiest. It's easiest. So const info is this. So the shallow analysis of this constant will return the new transformed, the resolved declaration of a constant, in which we have done some basic checks, namely we have verified that the type exists. So what do we have to do here? This is a const info. The only thing we have to do is type name is resolve the const type. Once that's done, we can return a shallow and therefore wrong const info with the identifier. The type name. And I'm very tempted to use laziness and put something that will error, because we should never use the evaluated expression of I feel like, especially in Haskell, I have failed if I end up using types that have values that should not be used. It means my representation is slightly incorrect. I guess I could use a intermediary phase between between parsed and resolved, and I could have a separate hash map for the local definitions in which I am in that phase, and in that phase, expressions are still left unresolved. Ah. There is probably a better way to do this. I'm gonna continue with this plan for now because I want to make progress. My plan since the start has been, let's get something that works so we have a pipeline that actually compiles something, and then let's iterate to improve. So I think I'm gonna continue with this approach, but this is my own self-criticism of this approach. I am using values that should not be evaluated, and that's a sign that my representation of the domain space is lacking. So here I'm going to use a text expression, text literal expression, string literal expression. I don't know how it's called again. I think it's string literal expression. There we go. And internal compiler error. This should never be seen. Okay, so that's the shallow resolution. We need to define resolve, however. And resolve, I guess I could make it also. And we need to check that this is a type, actually. So let's do a resolve type. But resolve still needs to exist. Resolve is going to be something that takes an identifier, that actually takes a path, and will return in my analysis monad actually in the maybe-t analysis monad, because we will fail if we cannot do that, will return a name and maybe a declaration. Resolve of a path will do name is hoist maybe No, I don't want to do the hoist maybe yet because I want I want to I want to be able to report an error if it was wrong. So the name will be uses, which is the thing that uses a lens to apply something. My name, my context names, and the function I'm applying on my context names is a map lookup, and I'm looking up that path. That gives me maybe a non-empty list of names, which is equivalent technically to a list of names, but maybe non-empty has like slightly different semantics, despite being, isomorphic, kinda. Now, what I want to do, I have this lovely handle maybe thing, which is exactly what I want. I'm gonna use here a handle maybe of some diagnostic of the maybe value, and that's gonna give me the name, and I will only have this if the name existed. Otherwise, I will have short-circuited the analysis of that top-level declaration with the given diagnostic. And the given diagnostic is gonna be error name not found, which with an identifier, or actually a path, a path. I think the location there would be great as well. We'll see. Now, if I have the name, what can I do with this? I can do a lookup of the declaration, but it's fine if it fails because some things don't have associated declarations, such as built-in types. On that note, I am actually gonna distinguish built-in type and built-in function. Or do I say that, like, no, I think it's clearer to have this. Which means I go back on this and instead pure int built-in type int name. Okay. So here, let's get uses context. This is a lens no underscore context declarations, and I do a lookup of that name, but it's fine if it fails. That's a maybe value, but that's not something we should circuit on. And we return name declaration. Now, resolve type is going to be the same thing. Except we'll get the name and declaration from the resolve of the path, and now we have to check that this thing is a type. So case name of, if it's a built-in type, perfect. If it's a built-in function, that's one of those cases like tell, diagnostic, and then short circuit. And I could probably introduce an alias for this. Report fatal. which takes a diagnostic and returns and just like short circuits immediately. And this is just tell the diagnostic followed by M0, which I can probably rewrite 0.3 as being a tell. There we go. Pure. And that means here this is report fatal diagnostic. There we go. And here I can do a report fatal. And that's going to be a error, not a type. And I will probably want to, and I haven't done this yet, I will probably want my error reporting mechanism to report a diagnostic and attach the location where we are to it. And I will probably want the location to be a stack, so I can say in module X, in function Y, in like such declaration, here is the error. But I haven't done that yet. I wanted to go back to not this. Error, another type, and name, I guess. Identifier name. So the identifier is no, not an identifier. Diagnostic path. That's the path. That's the name. If it's a top level declaration, then case of the declaration of nothing internal compiler error. That should never happen. And here we can have a look at what kind of thing that is. Actually, if I resolve a type, do I want to always inline type aliases? No, I don't think I do, because in a lot of contexts, I don't care. Yeah, if I'm trying to resolve a function, then I don't need this resolve here to do the thing. I will only need when I do a type. So here it makes sense. So here we have. I'm missing one actually. I'm missing the const. There we go. If it's a constant, then error report fail not a type. If it's a type alias, this is interesting. If it's an enum struct, I don't care, it is all fine. And if it's a function, then report fail on the type. And I guess let's have a look at the type alias info. Aha, this is something I haven't thought about yet. How do I deal with generic parameters? Because it's not enough. The name thing will require to store the parameters. Names are going to need to be different than this. I'm going to need to change this. Because I cannot at the moment with my name, structure, encode type parameters. So here I will need to resolve the name type, which is a path, but has also, which also has type arguments. Okay, so I think I'm gonna just push that problem down the path, if I may say so, and say that this is okay. I found the type alias, but I need to know what the actual type is, so I need to unwrap this. So I need to, in the context, in the case of a type alias, I need to, oops. I need to resolve type alias. And resolving a type alias is something that is not done yet. That we will do later, when we have a better definition of name that allows us to keep track of type arguments. Unless for now we just ignore type arguments altogether and we don't do generic functions, but I would rather not take that many shortcuts, even if, again, I'm trying to do a first version. That feels like too big of a shortcut, at least for now. So this would be a type alias info. I guess this is basically finding the declaration of the type alias info, probably. What is the difference between doing this and doing a full proper resolution of... What is the difference between doing this and doing a full proper resolution of the type alias? A non-shallow one. That's basically the same thing, isn't it? Let's push that problem down the path for now. I am thinking about. Currently, my logic is I resolve every top level declaration, and the result of having a module being resolved is I have a hash map from each identifier in the module to a fully resolved declaration of that thing. Type aliases are kind of weird. For now, I have a unique name associated with them, but whenever I actually want the type of something, I will have to do the full resolution of them. So what sense does it make to have a resolved declaration at the top level if every time I use them, I'm going to have to do that kind of... Will I want the output of my analysis phase to not be here's the name and the declaration of that thing, but instead I want the fully resolved one? I think I don't. I think it's better to let every color actually do the resolution. I think it's simpler. But that's something I had not thought about and not considered. And that's something we'll have to figure out. So I think resolve type alias is something that I'm going to leave undefined for now. Just because I want to make progress. But therefore, resolve type, given a path in this context, will do a lookup in the context, look at all the things at that path. If there's only one that's perfect, Otherwise, oh, here is the result that I need to handle as well. Here I've handled the maybe, but name in the case where it succeeds is not one name, it's a non-empty list, and I need to be able to handle the case where it is not just one thing. So and so name is going to be names is actually the name of the first name and the others. And when the length, well, when non-null others report fatal, and this is going to be a new diagnostic. Error ambiguous name path. And this is going to be a non-empty list of name. And I guess I probably want the path as well. Error ambiguous path of this path, and that's the names. And that's fatal, therefore this will short circuit. Therefore we are here only if this did not happen. And we have the name, which is the first name of the non-empty list. That's fine. So this can stay the same. Okay, we have handled ambiguity. Okay, so we resolve a given name in the scope. What is associated to that name? If there's more than one, we signal the ambiguity, we return. Otherwise, we get a name. We do a lookup of the declaration, which might fail, which is fine. And it's a type, we do that, and then we check that the thing we got was a type. If it was not, we report an error. And if it's a type alias, we're gonna need to actually fully resolve that thing to be able to give a unique name that points to the thing. And we don't have that yet. Okay. But that is enough to do the shallow analysis of a const declaration. We just resolve the type. And we insert a shallow declaration that just has the type, which is enough for type checking purposes before we do the actual proper analysis. But because we want to have something in the map of something in the context for all top level declarations before we do the full analysis, because things might depend on one another. Okay. That's basically the equivalent, if you want, of doing a forward declaration in C++, where it's like, hey, there's a class named foo in the context. The details are going to be given later. That's kind of what we're emulating there. How do we do the shallow analysis of a type alias information? I don't think, do we resolve it here? I guess. I guess it's just that. I guess it's just the resolving the name. So that's just a call to this function we have done here that we haven't done yet. This is resolve type alias with the info. And I think that's all there is to it. And I think actually that's fine. That means when we export when we export the declaration out of the module, we'll have the fully resolved proper name, which will point to whatever the thing actually is. Therefore, another module that uses the import will have a look at the resolved declaration of a type alias and will have the proper name and will not need to do further resolution, I think. Wait. That's it. That's the thing that was wrong. Yeah. God damn it. I can't. I have another circular problem where the shallow resolution of a type alias of a type here requires type aliases to have been shadow resolved first. I have another circular thing that this shallow approach doesn't solve. Because I get the top level declaration. If it is something in scope, that means I would not get the correct one if it's something that points to I have the same problem again. This declaration only exists in the scope if I have done all the shallow ones first. Therefore, when I resolve the type, I am not doing that. Unless I do a shallow resolve type that only gets the name and not the declaration, and that's good enough for yeah, okay. I think God, this is tricky. Here, the type resolution of the shallow analysis does not check that the thing we resolved is a type. It just says what the name is. It just gives me, yeah, that thing has type that. And we do the full resolution of that name. We do the full resolution of that name when we do the full analysis. That's the only way to do this. Okay. So I think I'm gonna, for now, comment out resolve type and resolve type alias because those are going to be done during the non-shallow analysis, which I'm going to do later. So this is shallow resolve path. Or do I just do resolve? I will no longer have. No, I will still have that. So I think, yeah, I think I want to just this resolve path, which doesn't look up the declaration, just gives me the name that uniquely identifies the thing pointed by that, and that's enough for the shadow phase. And then the full phase will be able to dig because when we get to the full phase, we will have a declaration associated with each name. Okay, so pure name. Which means here I do resolve path of the const type. I get a name. That's good enough for now. For type alias declaration, I'm going to do the exact same. Which means I am going to just shallow resolve the name, get the name associated with that thing within the context, and not do any further resolution for the shallow phase. Resolve the path that is pointed by the alias value of the info. and return a type alias declaration, which is I need to redo it anyway. This is a type alias info with the new resolved I guess I can use the identifier here, but that's a bit gross, but that's fine. Identifier and the alias. Now I'll do the proper thing. This is alias name, alias params, and the new resolved type name. I'm going to do the same thing here using the const name. Okay, so that's shadow resolve. We only do check names and nothing more. For the enum, that's going to be trivial. Because I don't know why I am using the parameter of the phase on the enum. Because there is no point. An enum info is an enum info. There's no point. There's no difference there. I guess it looked nice to have all of them organized, but like there's nothing in the enum info that requires being translated. So the shadow declaration is going to be trivial. Because that's going to be basically the same thing. Now, for a struct declaration, I guess we're going to do the same thing. We do just the very shallow name resolution, do the names that are in there point to something that we can uniquely identify. If no, we have to bail, and we delegate the task of doing the proper resolution of this, like are those actually types, to when we do the proper resolution, the proper analysis. So this is going to be a struct is like the name parameters are going to remain unchanged. What it's going to change is in the non-empty list of fields, those paths are going to become be resolved. That's all there is to it. Can I do this with a lens? And the answer is yes. The question is, do I know how to do it with a lens? Because I am... well, no, I can't do that, can I? I probably can. I would like to try something, but it's never going to compile. I would like to, if I reload this, yeah, even the AST doesn't compile. Let me make the AST compile quickly. It's complaining about enum info. Yep, I can change this. There we go. Can I have the AST compile? The AST compiles. Okay. So I am curious about the type of the lens of struct info. It is able to return something where the parameter of the struct is different, so I could use a lens to do the transformation. but I don't remember because, okay, what I want to do here is I have this info thing, which is a struct info. I want to traverse, and for every field here, I want to replace this name type by the result of evaluating a very simple function on it, which is resolve path. That's it. That's all I want to do. And I can probably do that as being a lens applied on info. And that lens will be struct values, traverse, and then here I need to apply the function, and I never remember how that works. Because if it were just like set the value, I know the operator for that. But if it is actually applying some, if it's actually applying a function in the surrounding functor, I am not sure how to do that. Maybe it's just traverse. Because wait, type of the lens is takes a function. Yeah, I think that's it. I think that's it. The function I'm giving to struct values is traverse. The function I'm giving to traverse is traverse. And the function I'm giving to that traverse is resolve path. Is that correct? It might be. And if it is, I could probably do the same thing here, where this becomes alias value, which is the lens that points to the thing, of resolve path of the info. Okay. I think that's correct. We'll see when we try to compile. But that, if that works, it's going to be a tiny bit more succinct. I think the constant is the only one that can't do that because I need to also replace the expression. Okay. I am not convinced this is going to work. We'll see. Now, for functions, what do we have to do for functions? We only do a shallow analysis, which means the only thing we care about are the types of the arguments and the type of the return of the function, if provided. And the body of the function we will not do as part of this shallow analysis because it's not required for type checking of anything else in this module. That means, and here we are not going to be able to do that with the lens. I'm probably going to do this struct info deconstruction thing here again. So we want to reconstruct the same function, function info. I want to reconstruct the same function info, but with the things that need to be resolved, and the things that need to be omitted. So it will be ultimately pure of a function info in which The function name will not be modified. The function parameters will not be modified because they're the name of the parameters. So that is not changed. That's going to be part of the type checking. The arguments, however, will be the resolved arguments. The function type will be the resolved type, if any. And the body is going to be the empty list because this is a shallow dummy declaration. Which means we need to decide what resolved arguments and resolved type is. And the resolved arguments are going to be for each identifier and arg type, or rather arg name, arg type in the arguments. What is a function arg type? Aha, something by value or by reference. But in both cases, this is just something that points to a name. The result is going to be pure arg name. Well, not pure, but arg name of case arg type of, if it's by value of this path, resolve path, and if it's by reference, path, resolve path of this path. Okay. So that gives us the resolved arguments, and the resolved type is going to be essentially the same thing, because we can use for to traverse a maybe. So for fun type, if there is, so it is a traverse resolve path of the fun type. Well, except that's not true. And it's not true for this one either, is it? No, I think that's correct. I think it's correct. I'm using traverse to apply a function within this maybe that will return something in, and then yeah. No, I think it's correct. I think it is correct. If it is not, we will see it quickly. And resolved type. There we go. And now that should be all for the shallow declaration analysis. Whew. Which means now we should be able to finish this top level declaration. And we can move on to the full declaration analysis afterwards. The full declaration analysis, or rather deep, full is nice. I think I'm gonna keep full. Is the part where we're gonna need to actually do the work. And I think for now, I'm gonna leave the full declaration analysis doing absolutely nothing. I'm just gonna give its type. I'm just gonna give its type so I can check that everything compiles. So this is going to be, here it's gonna return the name for the symbol map, which is just the identifier, and the actual full resolve declaration, not the dummy one this time. And it's gonna do the same thing, except this name is not required. Module name is probably not required. And this is gonna be a somewhat similar structure, except I will probably delegate to actual functions for some of them, where for now this is all gonna be undefined because I've been writing code for more than 2 hours and I haven't tried to compile anything beyond just the AST module even once. And it's probably a good idea to try to compile this and see where it fails. Let's go. Surprisingly, it fails immediately. Let's see what's wrong. Non-empty location. That's because location is not in scope. I like seeing not unused imports. That's usually the sign that we are at modules that finally compile. Let's see. Okay. From list built-ins doesn't work because, yep, this creates a map from name to from identifier to name, and I want from identifier to non-empty list of name. It's easier to just do a map pure on this to create a non-empty list from the one name. I guess run analysis doesn't have the maybe anymore because we delegate that to the maybe t that is added everywhere. I've called it analyze m here, and I've called it analysis m everywhere else. What names makes more sense? I think I slightly prefer analysis m. I'm gonna keep that. Okay, so I'm missing a few things. Let me actually check data list non-empty. I think it's called length. Or is it called size? It's called length. Small typos. Combine locations. Ah, yes. Ah, yes. Oops. I was a tiny bit more. I wanted to delete some extra old code and I was a bit too aggressive and I deleted my local functions for this. Oops. That's not too complicated to remake. Combined locations was just we have a name 1 and locations 1, and we have another tuple which is the name 2, which is always guaranteed to be the same because we are unifying by key, and the one identifier always have the same name in this context. And as a result, the result will be name 1 and the union of locations 1, locations 2. And I'm going to be missing the other helper function, which was... Oh, I don't think there was another one, actually. I thought there was. I thought I had another fold somewhere where I was doing... No, it seems I don't. Okay. Ah, yes, no, here. Make paths. What was make paths again? So, yes, I have my accumulator, which is my new, well, accumulator, which is my map, and I have, it's a fold with key. So I have the key to my map, which is the top level names, which is an identifier. And I have the value, which is the declaration. No, it's the name and the locations. And I don't care about the locations. I only care about the name. Because I'm creating context names. And as a result, what I care about is doing two insert into the accumulator. I'm going to do it the other way around this time. I'm going to do it with this. Insert. I need a path from the identifier that is just the identifier. That's pure identifier. To which I associate the name. And I need to insert for a path which is the module name, this name and pure of the identifier, and I associate the same name. Okay. I can type, it's as duplicate of an L. Identifier has duplicates, okay. This name. Yes, this name is something that I don't have as a function argument anymore. It is something that I have taken from the reader context. So it needs to be given here as an argument. I'm going to call it module name for this context. And here that means I have to do make paths module name. And this is starting to be a bit unreadable. So I might put this on a new line. There we go. Interesting. Because this would work. But that means this is not in scope? That's very interesting. I guess... Wait, it's not defined in controlled monad. Huh. You can't see Hugo when I do this. It's not. Fascinating. I was convinced this was just a flipped version of then. Huh. Okay. I was wrong. I guess it's because it might induce it might create confusion about the ordering of things. Context location is the lens for... except context locations is not the thing that exists. Context names, context declarations exist, but context locations is not something that makes sense. Oh, wait. Yes, because this used to be named context. This is info location. Okay. Couldn't match. Oh, because use, I think, is what I want. Uses would require a function to apply on the module name, and this is just getting the module name, not applying a function to it. There we go. Couldn't match analysis context with analysis info. Arising from. Oh, because use is something that gets from the state. Is it view? Lens getter? I think it's we had realized it was view that I was looking for last time. Yeah, view is when I want in the reader. So this is not use, but view. Let's see if I have, yep, here, view. There we go. Okay. Couldn't match. Oh, because I have a dollar here, that's not gonna work. There we go. Couldn't match non-empty name with name. What does that mean? So my hash map is a hash map from identifier to tuple name and non-empty list of. Wait, no. It is a hash map from name to non-empty list of pair from identifier to non-empty list of pair of name and declaration. So that means if I want to, if I get the elements of this hash map, I get a list of non-empty list of pairs. If I want to use that to make a hash map, I need to concatenate this list of non-empty list. Now, how do I do that? First, let's check whether data hash map strict, the from list, can it take any traversable or does it require an actual list? It requires an actual list. I can't do it with any regular traversable because I guess I could do it as to list of mconcat, because the type of mconcat is given a monoid, a list of that monoid, concatenate them. Damn it. Non-empty lists are not a monoid. They are a semi-group, but not a monoid because they have no empty element. I guess I could instead, therefore, do a concat of map to list of the elements. Concat not in oh, because I have made a typo. Okay. We're almost there. This is, I'm expecting this to be a hash map from path to non-empty name non-empty name is wrong. What is in my code text again? This is a hash map from name to declaration resolved. Known symbols is a hash map from path to actually, no, I'm going to do it here because I have this complicated part, this as part of the complicated folds here. But that's a hash map. I'm going to leave this because it's impossible otherwise to know what's happening. This is a hash map from path to tuple name and non-empty list of maybe declaration. And I think here there's no reason for me to use the maybe declaration because I have changed my representation. So instead, this is just a non-empty declaration passed. No, declaration resolved. And here I'm taking the elements of the thing, which is the list of tuple of map to non-empty thing. Oh, so this is still wrong. Okay, because wait. I think this is completely wrong. I think this is completely wrong. I think this is wrong because am I conflating the names? I think I have something wrong here. Yes, this is wrong. This is a non-empty list of tuple name declaration resolved. There we go. That's what it is. That's why here I can do a first on the value. Wait, that makes no sense. That makes no sense. Okay, this function is a mess, and I'm getting lost in my own function. That means I need to rewrite it. Or at the very least, add comments so that I'm no longer lost and type annotations. So, what I'm doing is I am creating a list of symbols imported from each import statement, knowing that sometimes there can be more than one import statement from the same module. So I am created a list of for all of those names that are now in scope, here's the name that they match to, here's the declaration associated to them. But I need to be able to deduplicate names across the same module, but not deduplicate them across different modules. For instance, if I import foo twice from the same module, that's one entry in the map. If I import a thing named foo from two different modules, that's two different entries. The way I do this is with this gigantic nonsense, where I fold with a union on the hash map, for which the key is the module name. So to a module name, I associate a hash map. I fold all of them to get one entry per key, so I deduplicate for the module. I get the elements, so I disregard the key, which is the module name, and I get all of my hash maps from name to things, from identifier, from path to things, and then I fold them, but I fold the non-empty lists. Okay, so that means this thing, after I'm done, is a hash map from path to non-empty list of tuple name declaration. Okay, that means the context names is not this. This is incorrect because my context names requires a hash map to path to non-empty name. So this is actually fmap first. I am changing the value of my hash map to apply within an empty name first to get a hash map from path to non-empty name. Okay, and here I am getting the elements of the hash map, so I'm discarding the keys, which means I get a non-empty list of tuple name declaration, which I want to use as a pair key value to create a new hash map. I do a to list, a concat map to list, so that I have a list of non-empty lists. I transform each of them into a list and I concatenate. And from that, I can do a from list. Okay, that should be good now. And yeah, the next error is in the next function, so that is fine. Okay. So I am going to comment this out because it took me having to re-explain it out loud to figure it out. Can I add a type annotation here? Will this work, or do I need to do something like this and indent this one more? I think I have to indent this one more, and that means known symbols is a hash map from module name to hash map of path to non-empty tuple of name and declaration resolved. Okay, so at least what's happening here is clearer. Okay. Here we group the declarations per module using on the hash map. This discards duplicates within the same module, as the same module might appear more than once in the list of imports. We then concatenate the non empty list, which confusingly is also a union with, but on the non-empty list. The result is a hash map from path to grouped non-empty list of possible matches across modules. Okay, with the comment saying explicitly what we're doing and the types saying explicitly what the different hash maps are, I think this is starting to be, if not readable, at least a tiny bit better. Now, what's the next error? And I have made a mistake when I've typed this. It's a list. It is a list of hash maps. Okay. Now, in its local names. So here I am doing a fold L prime. I am using union with combined locations, starting from an accumulator, which is an empty map. And the list on which I am doing this fold is... Why do I concatenate? I think this concatenate might be wrong. I get the declaration from this list of declarations, which is this one, which is the with location declaration passed. And yes, declaration identifier here, I need to actually, it's the located thing because this is wrapped in a with location. Okay. This returns this returns a tuple of identifier and top level declaration and look and the non-empty list of, okay. Wait, why do I do that? Because I want to group things by identifier. Okay. That means that my combined locations here is not correct. Yes, it is by identifier. Okay. Oh yeah, here I am doing the wait, what am I doing? I think I meant to do a fold L prime on the map, not on the list. That would make a lot more sense, I think. So this is supposed to be a M fold L prime. No, this is... What am I doing? This is wrong. Yes, this is a from list with. That's what it is. I have a list of pair of key values, and I create a hash map by using the provided function to combine values when they appear more than once. That's what it is. Not a manual fold. There we go. And the list I am creating this with is this one, which for each declaration I create this tuple key value. There we go. Okay, next. Why does it expect? Oh, because I'm saying union with combined locations. This is now just combined locations to know how to combine the different values. Okay. Couldn't match name with non-empty names. Okay, we're making progress. So this top level names is this hash map, which is my hash map from identifier to name a non-empty list of locations. Okay. And so something with make path is wrong. So I have the accumulator, which is my hash map. That's correct. I have my identifier here, which is the key. And I have name, which is... Oh, yes, I suppose it needs to be a non-empty list of names, because the hash map contains a non-empty list of names. Therefore, I need to... Can't I just... Why am I doing a fold with key prime here? Oh, because I'm to a one value in the map, I'm associated two values in the resulting map. That's why. Yes. So here, this is pure name. Pure name. And I think that's correct. Okay. Handle maybe takes one diagnostic as an argument, not a list. Not no others. None is something else. I think it's a lens. Okay. Uses is wrong. This is view. Aha. We're about to see if my lens approach is correct or not. I am not holding my breath. So, resolve path of the const type. Oh, that's because it's a path info. Aha. That means none of this works. So this needs to be a path info, and I need to... Since I don't have a way to represent in the name at the moment the type arguments, I'm gonna disregard them for now, which means I need to fix my name type, but for now, path info, I'm just gonna use the path name. So whether I have path, I'm gonna use instead path name, path name, path name. Okay. Okay, what's wrong here? I am returning a const declaration, which contains a const info that contains the const name, the type name, which is the resolve type name, and a string literal expression. Oh, because this function is supposed to return a tuple of name and okay. Can't I do simply a this name here at the beginning of this? I think that should work. Okay. Okay, so this is type alias declaration of this. This seems to have worked otherwise. Okay. And this is a struct declaration. So my weird lens stuff seems to have worked. And here this requires the function declaration wrapper. There we go. Okay. Oh, this needs to be a function archetype. Okay, so I need to properly recreate this. There we go. I align this as well. Okay, no instance from a hashable name. Okay, that makes sense, I suppose. So now it's time to go fix name. So, what do we need name to be? Because this enum thing is not enough information. It does not capture a lot of things, such as it doesn't capture the arguments added to the thing. For instance, when I do say that the name of something, I need to be able to point, okay, this points to this, but also here are the arguments provided to it. So I suppose, what is a JHC name again? I don't remember what that is. Not because I'm going to do the exact same, because I want to remember how they've done it. Because I think it was useful to have that reference. I think it was in types, wasn't it? Because if I remember correctly, it is a record that contains this kind of enum that says where the thing is from and adds additional information. Let's see. So name is name sort, where the name occurs from, the unique identifier to like sort things that we don't need, and the definition site, which for us is location. So external module, where it in internal system. That's kind of my top level thing. Versus built-in, I guess, for us. And the OCC name is something else, which I think is there. What is an OCC name? I don't remember what that is. Where is it from? It's probably imported from something else. Yep. Where is it imported from? It is imported from type name occurrence. Ah, gotcha. Variable name, field name, data name, and so on. I think that's kind of a mix of. I think that's kind of a mix of the different things that we're doing. And since we're doing something slightly different, like the type arguments are going to be a pain for us anyway. But I think that means we need to do something somewhat similar. I think the proper thing would be to have. I mean, module name needs to be fixed anyway. But that means a name should be a record of the type. Which is this thing. And do I want to always have module name and identifier? No, I think it's fine to have just this thing, but also have the arguments. Because this thing is enough to uniquely identify, it's just not enough information for what we need to store. Unless I decide that this is enough for a name, and however what we store in the AST is that augmented with something else. As in, yeah, it points to that name with those arguments. I think I prefer this, because I think the arguments don't make sense in the name. So I keep name the same. Oh, and I will need to have. I can't derive hashable unless I make this generic, I guess. But I think that's fine. Deriving, and I will need to say generic here. And then deriving instance hashable, I think. I'm gonna need import GHC generics, I think. And I'm gonna need import data hashable. I think it's just instance hashable name. We're not deriving it, we're just using the default implementation that relies on generic. I think that's where it is. Okay. So that's what we're gonna do. Actually, I could try to compile this first, and then I could switch to the AST having a better representation of the name. This requires EQ. Easy. I hope identifier has EQ, but it should. Okay, data hashable is redundant, I guess, because my prelude already puts that in scope. Likewise for generics. Perfect. Perfect. Okay. The import is redundant. We like those errors. They only happen when we are done. Unused this name. Interesting. That's good. We take not having to take stuff from the context. Always good. Unuse here in the code we have left undefined. And here is in the test, we have an arbitrary enuminfo passed, but enuminfo no longer has a type argument because it is independent from the phase, because it's just a list of identifiers and nothing needs to be resolved. Okay. For now, at least. I guess maybe I should have kept the parameter in case I change my mind. We can just put it back. Okay, and this compiles and the tests pass. Now, probably want to try at some point, but it's hard to try with something that's like partially done. I wanted to change something. I wanted to change what the name type is during the phase where we have resolved the thing. This is here, this is just a path info, which has wait. What's path info again? Yeah, I think what I want is just the path info, as in something that points to a name, whatever that is. I think I want that in both cases. So I think what I want to do is, in fact, rather than having path info when it's passed and name afterwards, I think I want to have path when it's passed and name when it's passed, and keep the same path info in both cases that allows me to encode we're pointing to this thing with those arguments. I think that's the correct approach. So I need to change to bring the path can stay here, that's fine. I'm gonna bring back path info here in the group of the things that are parameterized by what's called, is it called, it's an AST phase. And here is where this is parameterized by a path info of P, and this is the name type. So now I have a bunch of places where I use name type, where I used to replace by path info. So let's have a look at name type. So that's not a name type, that's a path info. Part of my issue is having chosen to make a language that's quite complex. The thing is, I did not want to make a trivial language that only has ints, doesn't have like data records, just like as ints and basic operations, because by now it would be done. It would be a lot easier. But I thought the more shortcuts I take, the easier I make my language, the less this exercise becomes relevant, and the more I'm writing something very specific to my problem, and the less am I writing an actual compiler for a thing. And I think even if at some point I'm making some, like, I'm taking some shortcuts, I am making code that's a bit specific to what I'm doing, still having ambitious goals means this is still more interesting than if I had just made like basic int language. Path info. It's 11 already. Path expression here. That is a path info. And I think that's it. Okay. This should not break anything, famous last words. I am going to put you at the bottom there so that it's consistent with the way I have defined everything else. And this is going to require the constant, which is called pretty constraints of the phase type. There we go. And here I can no longer use the deriving show. I need to do this. Couldn't match. Okay, so aha, this is making an assumption about the shape of the name, which is something that I cannot know, which means here I need to instead pretty the path name, and I'm going to need to add an instance of pretty for path. Which is just that. Okay. Overlapping instances. Aha, because I already have, there is already an instance of pretty for non-empty list. Hmm. Can I just do something ugly and do an overlapping here? I guess that is technically an orphan instance. Hmm. I guess something I could do is I could decide that I have no need for a pretty printer of any other phase than the past phase, because that is mostly used for tests, it's not used for anything else. So maybe it makes no sense to do a pretty printer for any other version. So perhaps I can save myself a lot of trouble and not try to support something I don't actually need. Just keep this. Remove the pretty constraints. Remove this. And finally, what am I doing wrong here? Yes, there we go. This is now pretty \1 past. And that simplifies a bunch of things because that is no longer something that is required. With a bit of luck, I can remove all of the calls to within. Can I even do that? Or will it be confused? Yes. Okay. Because I am no longer in a context where this is ambiguous. Which is great. I can remove a bunch of type annotations. At least I hope that the within will still compile, but I think they did. Okay, and pretty constraints is no longer something that is required. There we go. And this for all is probably not required either because I don't need those type annotations. Yeah, there we go. Okay. Haha. Okay, so this still requires, this is within expression. Will it be happy with just that, or will I need to specify? I will need. Okay, so the withins still required, still require the explicit. That's annoying. Okay, so that's expression and past. I should have known. It was too easy. Oh, yes. That's also. I'm just gonna copy it. Okay, so go needs to be annotated as well, which is the same thing. Is that all? Nope. This within it's the statement now. Okay, and that's it. Except, aha, I thought I was done with happy, but nope. We have a few last things to change because I have a few places here where I written a path info, and there is now a path info past. Where else do I have a path info in this file? Path info past. The types within are the same, so things within are not gonna change. The path info here, the constructor is the same. Path info past. Okay, that should be fine. How's everyone? It's been a while. I've just been hammering at the keyboard, compiling everything for an hour at this point. I'm glad to hear that. Okay, so now we're getting errors back within the analysis, which is good. That means everything else has been fixed. And that's good because resolve path takes a path info parsed And what it needs to return is, of course, now a parse, a path info resolved. Ooh, fun. Yeah, this project is a bit ambitious, but working with compilers is, I find it a ton of fun, and I'm having fun with this. And I hope I'm able to. I don't know how to phrase this. I hope that my enjoyment of compilers and languages at large is somewhat contagious, because that's kind of the goal. Okay, so now we need to fix this. And this is going to be interesting because now because a path info contains path info because if the path info is, if the type is a vector of vector of vector of int, then I need to resolve vector and I need to resolve the vector within and so on. So this gives me, so the name will be the resolved version of the path name, but I will need to create a path info resolved that contains that name, but recursively I need to resolve the paths within. So that means the arguments, is it called arguments? Params. Oops. Params are going to be obtained by traverse resolve path on the path params. And the result of this is if we have succeeded, then we can return a new path info with the resolved name and the resolved params. Okay. Arbitrary path info. Path info here, I'm going to need... Yes, all of my arbitrary are for the past version. And now we are back to something that compiles. Okay. Can I test all of this? I guess I can try. There is something I can do. Because here I do the thing where, like, first I get the shadow declarations, then I do the full analysis. If for now, if I cheat, if for now I go do a module name is view info module name. And for each of them, what I do is the identifier name will be the declaration identifier of located, which means I know for sure the name because it is it is this top level declaration module name identifier name. I guess just identifier. And that means I can return uses, which is something that apply a lens to the state and then apply a function to it. I am going to use the lens for context declarations. And what I'm going to apply on it is a hard lookup that panics if it doesn't find it of this name. Basically, I am returning the shallow declaration we created before, not the full one, which is wrong, but is no longer an undefined and therefore will no longer panic if we try to use this. Which means I can try to do something. Yes. Okay. So that's correct. I can do something. I can change the main that is here. Because I have like the main, this is the main that's going to be at some point the main for a compiler that passes the options and does all the things, which for now passes a module, doesn't even give the proper like file name for errors or anything, and pretty prints the AST, which is just printing the same thing back, I assume, I guess. If I go back here, if I stack build, if I stack run PC of, I guess, test examples, test, is it end-to-end? Or is it, no, I think it's integration. Integration passing basic PI. PC being, of course, the Piètre compiler. Does it have to recompile it? That seems weird. But I guess that's what's happening under the hood. Any second now. What's happening? I guess it was still compiling. Oh, get contents. Okay. Okay. There we go. So it takes the file, reads the file from the standard input, and pretty prints it back. So it just runs the pretty printer on the file. Okay. So it means we could just reuse this like empty program for now, and instead we get the AST, which is the past version, and we can call analyze module on this, assuming that there is no imports, of course. There's a bunch of imports. Okay. I guess I could create fake imports. One thing at a time. One thing at a time. Analyze module. So this is going to be, I'm going to call print of analyze module. We have an empty hash map for now. So we're not going to be testing the resolving the modules just yet. We can do that later. The module name is just a path. I'm going to set language overloaded lists. So I can define my non-empty list with a list. And it's going to be main. And what else we need? We need the module. Okay. Which is the AST. Okay, and I just need to make sure that this, okay, stages parsing, stages analysis. Okay. And now I need one last thing. I need a very small test file. What will it contain? What's the syntax again? Something like that. Is this good enough? Let's see. If I do this and I run this with this test file. What I'm expecting is a print of the show instance of the, if it compiles, of course, of the resolved AST, which is going to be quite messy because the default show instance is going to be, you know, a show instance. So, but still, that's going to be useful to see what that looks like. Yes. Okay, MMT, not imported, but I guess I can just use the fact that hash maps have a monoid instance and use MMT instead. Okay. Aha, so that didn't pass. Something is wrong with my on left print E. On left print, I guess. Yeah. On left error dot show. This is not proper code. This is ugly. This is just to get something. Pass error operator assign, expecting. Okay. That means, and this is on line 7. I'm guessing this is because the constant requires a type which is not given. I'm going to say it's an int. Okay. So here we get an actual error. An error name not found. So we got 2 diagnostic errors of error name not found because we tried to resolve something named int and that failed. This name not found error is from here. That means we are using context names and we did not find a path that is int. That means that our context was not initialized properly. Or that at some point we did erase what it contained. So here we do a run analysis, and run analysis, which is defined here, runs the state with at first a map from list built-ins that do contain a path int that matches the built-in type int. So at some point, this context names, the int gets lost. That would in all, I suppose it would be during the imported context and the local names. I probably at some point, yes, here, I do a context names and I set the value of the names rather than combining it with the existing one. And that's a mistake because the existing one already contains stuff from the built-ins. So I will instead combine it with the existing ones because the existing ones are only the built-ins and should not conflict with any of this. Therefore, a simple hashmap union should be enough. I was so proud of this lens operator, and it was wrong. Okay, so now I get no diagnostic, which is good, and we get this mess. If I try to sort this mess, to have one declaration per line, that's fine. Trying to align something that is not in a text format is not great, but that's fine. So we got 4 top-level declarations, main, X, foo, and bar. I think that corresponds to this main, X, foo, and bar. That is correct. Main is a function named main with no parameters, no arguments, so there was nothing to resolve. Maybe not a great test. X was a constant name X, and the type is indeed a path name to the built-in type int, so resolving this worked. Foo is a type alias declaration named foo with no parameters that points to a top-level declaration in the module name bar, so that's good. And finally, bar is a struct declaration in which perfect. Oh, but I will try something else. I will try something a bit more interesting. What if I have struct foo that contains a field A that is a bar, and struct bar that contains a field B that is a foo? This should work. The whole point of having the shallow resolving phase is that I am able to like not worry about the types yet because I only care about the names. Then the full resolution phase will care about this, which means I could go even one step. Let's do this test first. Okay. The struct name is foo, the struct values is A, and the path is a top-level declaration main bar. And for B, it is a top-level declaration of main foo. Perfect. And now if we try, this takes a type argument. This takes type argument. This is a bar of foo of int. This is a foo of bar of int. Pass error. Oh, because yes, this needs to be qualified like this. The field A is a path info where the type points to the top level declaration main bar, which uniquely identifies a bar, with the argument being a first argument is a path info to main foo, in which the argument is a path info to the built-in type int. Okay. So the shallow analysis seems to be working. Okay, now let's test some errors. If I have a const x, which is an int, which is equal to 0, and I have a second const x that is an int that is equal to 1, I should be getting error multiple declaration of x appearing at line 3 and at line 1. I guess the order is reversed. That's not great, but that's something that should not be too complicated to fix. Okay. Do I report all of the errors if I have a second set of constants that are also int? I'm just going to copy this. Multiple declaration y, multiple declaration x. Okay, perfect. So I should probably reverse my diagnostics, but that's another problem for later. What if I have a const x that happens to use a type that doesn't exist, such as float? Error name not found, that's fine. Okay. What kind of errors have we also implemented today? Oh, I should probably test imports. Multiple declaration we have tried. Name not found. Not a type is not something that's actually a problem yet. However, error ambiguous path is really something I want to try. So what do I do? Let's rewrite this thing here. Data text IO. Oops, that's not what I wanted. I think I wanted data text IO. This one. Get contents is getting the input. Is there a read file? Read file, perfect. Get contents. I'm going to replace the read file. Okay, so what I'm going to do instead of reading a file from the standard input, what I'm going to do is I'm going to get file names as get args, which I think, oh god, I never remember. Is it system environment? And what I'm going to do is I'm going to create the hash map of resolved thing by passing them one by one, assuming that the graph is correct and that they're given in proper increasing order, which is perfectly good enough for this evening's test. What that means is that I am going to do an exec flip exec state t. I'm going to import data hash map strict qualified as m to have it in scope. So I'm going to run a state monad with an empty hash map. And what I'm going to do in that state monad is for each file names, for each file in the list of file name, I am going to do retrieve the dependencies which is my hash map of module name to um, my hash map of module name to symbols by doing a get of the current state. I am going to do, let me have a quick look at, is it file path? System file path. How do I remove job extension? Okay. So take base name is what I want. Okay. It is system file path. System file path. So the module name, which is a non-empty list of identifiers for now, is gonna be just a list, a one element list containing take base name of the file name, which is probably gonna be a string. I'm gonna have to do a conversion from string to text here. We'll see if that doesn't compile. And then I get the content by doing a read file of that file name. Then I get the AST by parsing that module. And I get the symbols by doing analyze module of the current dependencies. The name is the module name. And I give it the AST that I have just passed. I align this, there we go. And I then do a put in my state. Well, actually modify. I modify my state to do insert into my hash map of dependencies at the key module name my new list of symbols. Okay? And that gives me the exec state will give me, let me check, I always get confused. I could have written it as a fold, but I like writing a state. I think exec state is the one that gives me the actual state. Yes, final state. Perfect. And that gives me, I don't even state T, I don't need to be on IO. That gives me the final state, which is the final hash map, and I can print that. Okay. This is not very elegant, but at least it means I can try testing imports and see if we have like proper errors on multiple on ambiguous names, and also that we don't have errors when the name is ambiguous but unused. Why is it recompiling so many things? What did I change that required? Oh, that's because I'm building stack test. So it's building with test mode enabled, while here the stack run would build without the test enabled. That's why it's rebuilding everything. Okay. Hiding read file. Is that the only error? I'm surprised. Clearly get args is giving me strings. Oh, and yeah, of course, this needs to be an exec state T because I'm doing IO and stuff, so this needs to be on top of IO. So that's gonna be the modules. Oh, I guess symbols, and here I can print symbols. Okay. Ah, this needs to be lifted from IO. Okay. I guess pass module requires IO? No. Oh, no, it's just because on left I do the error. Okay. So I guess, yeah, I need to do this properly. And here I can do, so that's diagnostics symbols. I can print the diagnostics always, no matter what. Or rather, when not null diagnostics, print module name diagnostics. And then case symbols of just, I can say results. Just symbols. We do this thing where we update the state to reflect the fact that we have successfully passed the module. Otherwise, then we did not successfully pass the thing. Just outright error. Aborting. Okay. Now I think the only error left is going to be the fact that module name needs to be a text and it is a string. Yeah, there we go. So that means I'm going to need import data.text qualified as t, and I'm going to need to do, this is going to be t pack, I think, to pack that string into some text. Okay, what's left? This is also lift IO. There we go. Okay, that builds. So now let's build a very simple test case. I'm going to create foo. Oh. That contains, do I want to do that with type or with, yeah, since I'm not resolving expressions, I need to do it with type for now. So struct foo with one field a, which is an int. And we'll have bar that also contains the struct foo with the field a, that is an int. It is the same thing. And we'll have main that declares a function main that returns a foo. Now, actually, I probably need to do that. If I do this and do this, pass error semicolon. Is it because I've put semicolons at the end of my yeah, that's exactly where it is. Yes, of course. My main doesn't have an import statement, which is use foo, I think. Error name not found. Okay. So my import doesn't work. So here I have this foo thing and I am looking for Let's see what the names are, because maybe it's just a problem of my actual lift IO print module name. Why is it recompiling? What have I done that justifies recompiling everything? I don't know. Okay. So the name is indeed correct, but I guess so. Who manages to finish without any? Huh. Okay. Well, I guess printf debugging, print symbols. Let me see what you have. Is it because... No, that can't be that. Wait, this error name not found. That's the resolve path. That's not... Oh, so it's not that the import is not found. So the import is found. It's the name foo that isn't. Interesting. Okay. Oh, wait. Yeah, yes, of course. I think this is incorrect. I want to use... My syntax is incorrect. What is the syntax again? Let's like look at the syntax for use statements. I never remember. It is colon colon star. That is what I want. Okay. And now that is fine. I can remove some of the prints just for readability. Because we have checked that this works as expected, roughly. Okay, so if I compile foo and then main compiles, and in the symbols from main, I have a function main that has a function type that is a foo that points to the top level declaration named foo in the module foo. Perfect. So that works. And if now I compile bar before, nope, it works. Which one does it find? It should not work, but it does. So, oh, no, of course it works. It's fine. Because in main here, I did not use bar. If I do that, then now, air ambiguous path, foo could be either the one declared in the module foo or the module bar. Okay, that seems to be working. Now, I want to check something else. I want to add in this foo thing, I want to add another type called bar, because I have zero imagination, which is also a... oh, let's be mortal, which... Let's do a type bar equals foo. And Well, since we're only doing shadow resolve, that's fine. It's not gonna make any difference. But now I do this, and I call the one named bar. And that should be fine, because it's okay to have several times the same name in scope, as long as I am not ambiguous about the way I'm calling it. And this compiles, it analyzes so far, and the top level and the fun type of this main function is the path name is the bar type in the foo module. We're good. And I think last thing I want to try is if I do foo, if I'm explicitly like this, then even if there's two things named foo in context, it should be clear which one it is. That works. Okay. Looks like resolving the very basic imports and the shallow level of just resolving type names so that we can do type checking, that seems to be working. Whew. That's always satisfying when it seems to be working on the first try. Eh, first try, kinda. Is there anything else I want to check? We've tested the imports, we've tested... Is there any error that we have implemented that we have not tried yet? Not type is not implemented yet. Ambiguous path we have tried. Name not found we have tried. Multiple declaration we have tried. Import path and import symbol we have not tried this evening. And that's going to be easy to test. I guess if I try to import from Baz, I'll get an error because that's not a thing that exists. Okay, and I guess if I try to import from bar, but I didn't compile bar first, I'll get the same error. Yep. And I guess if I try to import a symbol that doesn't exist, such as a... There we go. Okay, that means that's manual testing. It's not very good yet. We will need to automate a lot of this. But so far, what we have written this evening and what we have changed from Tuesday, it seems to be working. No, I guess it's close to midnight. I should probably stop here. But I'm tempted to try to make some progress on the full analysis of types, because some of it is not that complicated. Because structs, it's basically the same thing, except we have to check that they are types, basically. Type alias same, except we need to fully resolve. Yeah, I think anything that has expressions, I am not going to do this evening, because both functions and constants, there's going to be some tricky things. But structs and type aliases, I mean, enums, there's nothing to do. It's already done. So that means I can try. Okay, let's try. I'm gonna copy all of this right here. Up, there we go, with just the identifier. Okay. And the difference is, so this is identifier here, but otherwise it's the same. And what's going to differ is, so for an enum, I do not care about the info. It is purely... I guess I can do that always. as in shallow shallow version, shallow info is this, which will be correct. I guess I should probably do a lookup here. And on left, if, well, on nothing, if we didn't find the shallow information for this particular thing, that means something went wrong. This is an internal compiler error. I don't have yet any proper error handling for this, but it will be something that tries to be smarter than this, but it's basically internal compiler error, because that is not supposed to happen. That is not a mistake on the part of the user. That's a mistake on my part. So for an enum declaration, purely return the shallow info. Nothing has changed. That's one that is out of the way. For function declaration function info, I am gonna make all of this undefined, because that's not something I'm gonna do this evening because it's getting late. For the const declaration, likewise, I'm just gonna make it undefined because going through expressions is something that is too long for this evening for me to do. So the enum is the trivial one, so we can keep it at 1. And I'm left with type alias and struct declaration. And those two are purely resolving names, so I think I can try them. I guess I'm going to have a need for this resolve type function I had started, which tries to check that something is a type. So that's going to take a path info. Do I want to start? Do I want to start from the resolved version? I guess I do, because I already have the name. So I have a path info resolved, and I want to return another path info resolved, but I want to be the one in which first we have checked that everything is a type, and 2, we have fully inlined the type, as in if any of it was type aliases, we have fully inlined it. That means what does that mean? We have a path info. And I can do a basic case on the name, which now is our name type. If it's a built-in type, I have to now do analysis of the arguments. I need to check that the arguments are types and that the number of arguments matches built-in types. Oh, I don't have information about the number of arguments about built-in types. I will have to change that. Because for now, if I do int parameterized by foo, whatever, I have no information about int that tells me that it is. I guess I could make a made-up declaration for. I could make a made-up declaration for int and stuff that would check the number of arguments. Or maybe have the built-in times be themselves type aliases for something built in underneath. That just pushes the problem down one. I'll have to think about it. for now, I'm just going to say I don't check arguments on built-in type. On a built-in function, that's an error. If it's a top-level declaration, then I'll need to do a lookup of the declaration. So the declaration will be a uses context declarations, and we do a lookup of the path name. If we found a top-level declaration that doesn't have an associated declaration, internal compiler error. Otherwise, which I can't do ahead of time because it could be there might not be a declaration for those. Now, if we find something, if we did find a type alias, then we need to resolve the type alias itself. Oh. But I need to override the arguments, do I? Oh, argument checking is going to be complicated here. So I have yeah, okay, that's going to be complicated. I'm going to need to check. No, it's fine. That's fine. I resolve the type alias recursively. And then from the result, I can perform the argument check. As in, I got the actual path info from this. I can check that the arguments that I was given match the things that I'm giving to It's gonna be something along those lines, but I can't see it right now, so I'm not gonna do more because I'm struggling to figure out how that's gonna work. And yeah, if there's anything else, that's a type. There's nothing else to do. Do I need to do any substitution? I think not at this point. So I think this is basically correct. What I'm missing is checking the arguments if it's a built-in type and resolving the type alias properly if the type alias points to a type alias, basically. But I'm struggling to see how I'm going to do that. So I think rather than trying to do this evening, I'm going to call it quits here, compile this, comment this back so I can get back to something that works. Comment this again to get back to something I can test again, even if it's manually. This is going to be pure shallow info. Check that the tests still pass. Almost. Look up this name. Prelude on nothing. It requires it's an on nothing M. I should be using. Okay. And this requires the identifier here. There we go. I didn't save. That's why. Now we should be back to something that compiled, even if it's still very wrong here. At least we have something that passes the very few tests we have for now, and I'm back to being able to do those tests where I compile things on the command line and I see what happens. Well, that was a productive evening. That's 4 hours of it, but we did finally get out of the struggle of getting started with the analysis, finding proper representation for names and stuff. I'm not sure this is still the definitive version, but at least we are at a point where we're making progress. And the shallow thing, as much as I don't like the idea of having types that contain the fact that my representation, the way I model with types, my problem ends up with values that should not be used, is not great. But at least we're making progress. So next time we do the proper type resolution, which means we can do a proper actual compilation of the type alias stuff and the structs. And then we move on to expressions. And expressions are not going to be too complicated. Famous last words. But most of them, like in functions, it's not going to be too complicated. It's just mostly checking that like types align and that when we resolve names, they are like the types are correct. Annotating types in expressions. And handling scope properly for variables, local variables and stuff. And the difficult thing is going to be for expressions, for constants, I'm going to do some constant unfolding, as in basically constants should be able to be computed at compile time. So we will try to compute the constants at compile time. The only difficulty there is constants can reference other constants, but they cannot form loops. And with that model I have today, that means that whenever I find a constant, I will need to be able to like prevent loops somehow. And I think since I will have no guarantee that the other constant has already been resolved, I think the only way I can actually do that properly with my current structure is to go look up the definition, the past, the unresolved definition of the constant and inline it, basically. Check that the types are correct, and then go look at the definition and inline it. Okay. I guess I could, as part of the shallow resolution of constants, I guess I could just do. Would it make sense to actually do the name resolving, all the name resolving at this shallow version, and then do the proper type checking? Does that make sense? Wait. I'll have to think about it. Okay, that's enough for this evening. I'll have to think about it. I'll be back on Tuesday, and hopefully on Tuesday we make some good progress on this. And I don't think we'll finish the analysis on Tuesday. There's too much to do still in terms of like type checking and everything. But hopefully we are now at the point where we don't have any of the issues we had at first of like how do we model any of this. We can make progress, and hopefully in a few weeks we can start the lowering into IR, which is going to be another can of worms. In the meantime, thank you for tuning in. I hope you all have a good weekend, and I'll see you all on Tuesday.